Welcome to Season 16 of Seen from Above. I'm Julia Wagemann, co-founder of thriveGEO. This season features 4 episodes highlighting winning teams and outcomes from the GenAI for Geospatial Challenge, an initiative by AWS and thriveGEO that awards cloud credits and technical support to innovators across Europe, the Middle East, and Africa, developing bold, generative AI-powered geospatial solutions for global challenges. In this episode, I speak with Reda Haidar, Commercial Director at RASID. RASID is a geospatial AI company turning Earth observation data into operational intelligence. Reda's team was selected as one of the winning teams of the GenAI for Geospatial Challenge EMEA edition, receiving AWS cloud credits to develop GoPilot, an agentic AI platform that let users interrogate satellite data using plain English. What began as a methane monitoring tool for detecting emissions has evolved into a broader geospatial reasoning assistant capable of orchestrating analytical workflows across multiple datasets. In this episode, we learn more from him about how generative AI is transforming geospatial intelligence, the journey from a single use case to a multi-sector platform, and where he sees the industry heading in the next 5 years. Hi, Reda.
Hello, Julia. Proud to be here, and thank you for having me.
So your company, RASID, and your team are one of the 14 winning teams of the GenAI for Geospatial Challenge EMEA edition. Before we start talking a bit more about what you developed during the challenge, could you tell us a bit about yourself and your role at your company?
Yeah, sure. So I'm Reda Haidar, the commercial director at RASID. RASID was established in 2025. However, the team has been working together for more than a decade in the field of geospatial AI and Earth observation and remote sensing. My role sits at the intersection of technology and strategy and business development. I work closely with customers and partners and industry stakeholders to understand their operational challenges and help translate our technical innovation into real-world solutions. One of the things that excites me the most is seeing how advanced AI are changing the way organizations interact and with geospatial data. To that point, the AWS challenge gave us fantastic opportunity to explore that transformation and ultimately led to the development of GoPilot, our agentic AI tool. So RASID is a geospatial AI company focused on turning Earth observation data into operational intelligence. We have a multidisciplinary team combining expertise in AI and Earth observation and software engineering and geospatial analytics. Our project is called GoPilot. It's an agentic Earth observation platform that allows users to interact with geospatial intelligence through basic human words. The original use case through which we got selected was methane monitoring through our proprietary system, Methane Mapper. It detects methane emissions from satellite imagery. But during the challenge, the project evolved into something much broader, a geospatial AI assistant that can reason across multiple data sets and orchestrate analytical workflows and answer operational questions conversationally.
So you started with specifically like the case study or like the problem on methane monitoring and get more insights on it. You said now you have like a more broader application. So would you say GoPilot is not only on methane monitoring, or it still has like the focus area on methane monitoring?
It's broader. So essentially, any Earth observation information that requires analytics and processing can now be derived through GoPilot. One of those is methane leakages and the sort.
Okay. So how did you first identify the problem or the need to identify methane leakages and that you discovered that is something that needs addressing?
Well, I would say through conversations with organizations across environmental monitoring and energy and agriculture and infrastructure sectors. We consistently saw the same challenge. There was no shortage of data, but there was a shortage of actionable intelligence. Let me explain here. Many teams had access to satellite imagery and geospatial platforms, yet extracting meaningful insights still requires significant expertise and manual effort. Methane monitoring was one of the clearest examples with this gap. A methane plume, as they call them, by itself isn't meaningful. You need context. Is it persistent? Is it near infrastructure? Is it a real emission event or just environmental noise? That realization pushed us towards building a system that doesn't just visualize geospatial information, but actually reasons about it.
Excellent. Yeah, it's actually addressing one of the key challenges with geospatial data, that you often see like nice maps or like nice data layers, but as you said, you often need context of bringing these data into the specific contexts to really generate insights and intelligence. So no, great to hear. So yeah, you already said like you now developed GoPilot, and maybe you could also try in simple terms to walk us through how your solution works.
Excellent. So you're a user. Imagine you are an environmental analyst. Instead of opening multiple GIS tools, searching satellite archives, downloading imagery, and running workflows manually, you simply type prompts like, I don't know, investigate facility X and tell me if there have been methane emissions during the last 6 months. Simple English. GoPilot would then handle the entire investigation on your behalf. It retrieves satellite imagery, finds relevant data sets, and runs AI models and analyzes historical patterns, even, and compares multiple information sources and returns a clear answer with supporting evidence to your question. So, in short, instead of you navigating complex geospatial workflows, you simply ask a question and receive actionable intelligence.
Excellent. So when the challenge is on generative AI and geospatial, what role does generative AI play specifically now in your application?
Yeah. One of our biggest learnings is that GenAI's superpower isn't detecting methane, it's reasoning. So methane detection still relies on specialized machine learning models like Methane Mapper. The LLM acts as the reasoning layer. It understands user intent, selects the right tools, and retrieves data, and coordinates workflows and synthesizes results. That's something traditional systems struggle to do because they rely on predefined workflows and fixed interfaces. The combination of specialized geospatial AI and generative AI reasoning creates a much more flexible and powerful system.
That's really exciting to hear. I'd be interested because now you were part of like around 6 months of the development phase of the challenge. So, and you said at the beginning that you also had like a bit of a pivot. So your application became much broader. So what surprised you most during the development process?
I would say the biggest surprise wasn't actually technical. It was realizing that the architecture we built for methane monitoring worked equally well in areas like agriculture, environmental monitoring, and infrastructure analysis, and also in change detection. You see, once users could interact conversationally with the geospatial data, they started asking questions and exploring use cases we hadn't originally anticipated. That's when we realized we weren't just building a methane monitoring tool, and that we're actually building a geospatial reasoning platform. It turned out that methane is not the destination, but the starting point for us.
I liked it really, so that you really start with like something that evolved from conversations, but then you unleashed many more opportunities through the process. And so maybe you could walk us through a bit on how it was to work with AWS cloud credits and resources, and how it changed what you're able to achieve now.
The AWS credits were transformative. We've always used AWS, but like anyone else, especially that we're bootstrapping, we would look at saving those credits and using them in the smartest way possible. But thanks for the generous amount of credits we received, they allowed us to train models and generate synthetic data sets at scale. We were also enabled to experiment rapidly without constantly worrying about infrastructure limitations. That was a game changer. We built synthetic methane data sets. Just to give you an example about the scale, they contained more than 100,000 simulated plumes. We trained the model using SageMaker and developed GoPilot using Bedrock and Agent Core. More importantly, AWS gave us the freedom to experiment, and a big number of the most valuable outcomes emerged from that experimentations.
Wow, that's really great. So were there during the journey also unexpected insights that have emerged from combining AI and also the AWS tools you mentioned with geospatial data?
Yeah, I like it because you're taking me through the journey of discovery. We discovered that the same reasoning architecture can apply across very different domains. as I said earlier, methane monitoring, agriculture intelligence, change detection, infrastructure monitoring, even environmental analysis, they might appear very different on the surface. But underneath, they are often solving the same problem, which is understanding how a certain environment changes over time and identifying meaningful anomalies. That realization significantly expanded our vision towards our new aggregation solution, the GoPilot.
And now, like you said, going from unexpected insights and unleashing additional possibilities and opportunities,
Mhm.
what were the biggest technical challenges you faced, and how did you then overcome these challenges to really build GoPilot?
But technically, as I gathered from the team, building several complex systems simultaneously was challenging. We were developing a synthetic methane generation pipeline and training deep learning models and migrating workflows to AWS and building an agentic platform all at the same time. So creating realistic synthetic methane plumes was particularly challenging because we had to model methane physics and atmospheric behavior and satellite sensor characteristics accurately enough in order for the model to generalize to real world observations. Fortunately, the results have been encouraging with strong validation against real methane events. Again, thanks to the credits and being able to train and validate at scale.
It remains the biggest challenge, like bringing different data sources together and also having like the real validation of the data to know the results that are produced reflect the real measurements. So regarding like developing AI solutions and specifically also Gen AI, you already touched there multiple of different technologies involved. And we all are, I would say, on the starting point of exploring how these systems are built up and set up and what components are part of it. So how did you specifically brought your team together for this challenge to make sure that you have the exact expertise on the team to build something within 6 months?
Yeah. I mean, most of us have collaborated previously on geospatial AI and Earth observation projects for more than a decade. You see, the technical team is far older than RASID itself. RASID is what brought them together a couple of years ago, but they've been around for a long time. The challenge brought together people with complementary skills in machine learning and remote sensing, cloud infrastructure, and software engineering in general. This combination was critical because building GoPilot required expertise across all of the domains simultaneously. But yeah, on the how, to come back to your question, we've known each other for a long while. It's like a big set of people that has interacted for a decade, and you can easily tap on this network and bring some expertise from it for certain projects.
So overall, how big was your team that worked throughout the 6 months of the challenge?
4 or 4.5 core developers across all the disciplines, and myself on the presentation commercial face of Prasid side.
Yes. And on one hand, for the challenge, you got like cloud credits from AWS, but this was like not the only part because you were selected with 13 other companies who proposed innovative ideas. And through this period, we also had like regular check-ins. And how did you benefit also from being part of like a bigger group of innovators in that space for a certain period of time?
The ecosystem itself was incredible. We were participating in the different touch points and learning about how the other contenders were progressing and using the credits and how they're also pivoting. Some of them pivoted like us, some more, some less. But for me, the biggest eye opener was on the floor on the, I think it was the 2nd of June when we were presenting, and this revelation of creating a side AI agent like our GoPilot to generalize the solution and make it more user friendly. Well, it was at least the case with 2 or 3 other contenders, which to me was at the beginning, oh, we're not that special. But then I figured out that the industry, it's moving in this direction and we are part of this move. So it actually brought pride. So yeah, I mean, this interaction across the pool of these companies or entities was incredible.
Yeah, that's often like a really important additional value because you also learn from the exchange because problems or challenges you face also others are facing. So for GoPilot, how do you measure success beyond the challenge itself? So let's say in the next 6 to 12 months.
Well, yeah. I mean, technical performance on one hand matters, but ultimately success comes down to user outcomes. We measure success by how much faster and easier we can help organizations move from a question to a decision. For example, if an environmental agency can investigate emissions more efficiently, or if an analyst can obtain actionable insights without needing deep GIS expertise, that's where we are really creating value. So our goal is to, in the next 12 months, I would say, to democratize access to geospatial intelligence, not just build state-of-the-art models, which we've done for a decade now.
So let's say if your solution and GoPilot was fully deployed today at your customer's premises, so what would it change for your customers and also the wider community?
Wow, thanks for the thought and for being as ambitious as I am. If this happens, organizations would ideally spend less time searching for data and more time acting on insights. Environmental agencies from our customers could investigate emissions faster. The agricultural stakeholders could monitor crop health more efficiently. And entities in the infrastructure sector could identify changes and risks sooner. So the broader impact is reducing, I'd say, the expertise barrier that traditionally limits access to advanced geospatial analytics.
So you could bring to your clients like faster decision making, also additional insights and information that is not available at the moment, or if yes, then it's like really complex to bring together. And so I would say it's good to be ambitious, and it's great to see RASID and you take on the challenge. Then with any solution, also with GoPilot, and specifically also in the challenge, it's about creating business opportunities. So what is your pathway to commercialization? How does it become a sustainable product or service? Do you already have some pilot clients for it? It would be great if you could elaborate a bit on that.
And this is where my value add to Rasid comes into place. So this is what keeps me up at night. The good news, Julia, is that we already operate as both SaaS geospatial intelligence platform and a provider of bespoke geospatial AI solutions. So this is what we did prior to the competition with AWS. GoPilot now becomes the intelligence layer across those offerings. So what's particularly exciting to me is that every conversation starts with methane and quickly expands beyond methane, creating, in my language, cross-sell opportunities. Organizations begin asking about agriculture, infrastructure monitoring, environmental compliance, disaster response, and many other use cases. That's a strong signal that we're building a platform rather than a single purpose application. We're currently engaging with organizations in all of those sectors: environmental, agriculture, infrastructure, and climate intelligence, to explore pilot deployments and commercial partnerships.
So if I understand correctly, basically it will not be like GoPilot, like a single solution that people can subscribe or you can pay for it, but rather it will be integrated already into your SaaS platform and will be offered there as an additional service to your existing client base.
Yes, that's right. For a brief period of time, GoPilot can and will be accessible for free for as long as we have some credits remaining from AWS, because that would allow a lot of feedback from the world, creating less barriers to entry or to usage in this case. But eventually, when it starts costing us money, we at least need to pass on this cost, and that's when it's, as you said, going to be part of our SaaS offering.
So your company is based in the Middle East, and so is your client base global or with a regional focus? And if it's only a regional focus, what would it need to also scale your solution globally?
To your point, the client base is global. We have clients from Mexico to the US to Africa, Middle East, clearly, some in Europe. Maybe we haven't done much in Asia Pac yet, but due to the nature of the business, once someone finds you or knows about you through word of mouth or networking for a certain expertise, the geographical location isn't a big problem. It's the imagery is coming from satellites, and the expertise can be anywhere in the world, really. To that end, we welcome interactions and engagements globally pretty much. I'm the only person doing commercial for now, so maybe I'm not being proactive enough about certain regions, but we can now with those expertise at least go out there and say we are the experts in this and that and try to expand. For me, any expansion is good, but we're not limited to a certain region for sure.
Okay, great. So how does your solution compare to what's currently available in the market?
The gas detection, and in particular, I don't want to say it's new, but it was less attended to because of newer imagery becoming available. When we say imagery, it's not always visual. It's sometimes taken with transponders that somehow give us as humans colors about certain emissions, but they're being detected with other means. That is a bit newer, the accuracy of those at least. Commercially, I would say that because of the training that we could do, 100,000 plus training images, as I said earlier, and the verifications of those, I think it's one of the most extensively trained in this particular domain. So yeah, that sets us apart in this one in particular. Similarly, for other solutions we've done in agriculture or urban planning, it's because we've detected different types of, roofs and crops in different kinds of geographies, because sometimes it's green, sometimes it's desert, and so on and so forth. We have a lot of trained models in the disciplines that we work in, and that's the edge generally with any AI. I mean, just like the AI we know about, the LLMs and those things, the more they train, the better they are. So our models, the disciplines that we created, are deeply trained, and in methane mapping in particular, it's being trained on newer data, and that is not abundantly available. So that in terms of time, at least sets us aside for us or apart. We stand out for the coming future. In that particular sense, we've been working with some leads in the region, in the Middle East region, and due to the oil and gas aspect on one hand and the way waste management is being done in this region on the other, methane mapping is of big implication.
Yeah, for sure. Now looking ahead, in 5 years' time, where do you see GoPilot evolve and also RASID?
In 5 years, I think geospatial intelligence will become largely autonomous from what I've seen. Organizations won't spend their time searching for data or building dashboards. They'll work alongside AI systems that continuously monitor the physical world and identify anomalies and investigate them. Then also surface actionable recommendations. The interaction model will shift from show me the data to tell me why or what it matters and why. That's the future we're building towards.
Thanks, Reda. This is like really an exciting time to be in geospatial. And yeah, it's just incredible to think of like, okay, what can be possible in 5 years' time. So really looking forward to seeing that. So one final question. Now the GenAI for Geospatial Challenge concludes. GoPilot has been very successful project, and the first pilot version is there. So what's now next for your team after the challenge?
Our immediate focus is expanding GoPilot capabilities and testing with more users and partners. As I said, AI, test, test, test. That's what you can do to keep enhancing it and increasing its learning. Methane monitoring remains important, but we're also exploring agricultural and environmental monitoring and infrastructure intelligence and additional Earth observation workflows. The challenge gave us the foundation. Now and going forward, we're focused on turning that foundation into production-ready geospatial reasoning platform.
I wish you, Reda, and your team all the best for this. It's really exciting, and I look forward to following your developments. And again, thank you so much for having you today on the podcast, and all the best.
You're welcome. Thank you very much, Julia.